Okay, we continue with descriptive statistics.
Okay.
Yeah. So we'll continue looking at the measures of central tendency. And today we are looking at what is called skewness. You'll find that when data is given in the distribution, it may not be equally distributed.
Okay.
Yes, so the values of the data or the element in the data set will tell us where the data is skewed. Is it left or right? Now, one of the key issues that you should consider about skewness is about the mean. We are saying if the mean is lower than the median, then your data is left skewed. Then if the mean is higher than the median, then the data is right skewed. And if your mean is equal to the median, then the data is equally distributed. So once the mean is equal to the median, then our data is equally distributed. Let's look at this example where we have got 12 elements. Now, from the look of things from this data, you are able to see that it begins with smaller values, then the values begin increasing, and we have got the biggest value at the far end of the data distribution.
Yes.
So once you look at this, you're able to see that our data is skewed to the right, because bigger values are happening or are being found after your median. So we are trying first to find our mean. As usual, our mean is summation of the data. When we add all these figures, we get 180.
80.
Yes, and we look at how many elements are in this data distribution. We have got 12 elements. So 180 divided by 12, it gives us 15. So that is our mean. Yes. So let's find our median. Since our measurements in our data distribution is an even number, then we need to pick the two measurements at the center, add them together and divide by 2. So since we have got 12 measurements, we count 1, 2, 3, 4, 5, and we count from the far right 1, 2, 3, 4, 5. We have got 2 measurements at the center, which is 10 and 10. These 2. Yes. So we are going to add those. 10 plus 10 divided by 2. We find 10. So our median is here, which is 10. So when you look at this, you agree with me that your median is lower than your mean. Meaning this data, much of its value is on the right. So higher values are on our right. We can use the same data again to calculate our variance. Since we know that our variance we know that our variance is equal to summation x minus x bar brackets squared. That is the formula for summation over n minus 1. So we have got our mean here.
The sign for summation.
The sign for summation.
Democracy. Yes, sir.
The sign for summation?
The sign for summation is S, no? Is S squared.
No, S squared.
No.
Variance.
The variance.
Exactly.
So
yes.
Variance. Yes, I meant variance.
Exactly.
Sorry.
Okay. So that is our variance. So all we need to do is to start adding these figures and subtracting these figures. Since our mean is 15, so we have got 2 minus 15 squared, 3 minus 15 squared, 8 minus 15 squared, up to the far end, 63 minus 15 squared. Then we add that. That is our summation x minus x bar squared.
Yes.
Exactly. Then our denominator is n minus 1. Since this is a sample, our n is 12, minus 1 gives us 11.
When I was working out this problem.
Yes.
Hello.
I'm hearing you.
When I was working out this problem.
Yes.
Yes, but the figure I got and the one which is there, they're quite different. Because at first I'd made a table.
Yes.
The figure for variance, because it was I had found something different.
Okay. Yeah.
But like the way you have explained.
Yes.
I made a table.
Yes.
Where I'd put elements.
Yes.
And then I'd put the mean.
Yes.
Then I was subtracting mean against the element.
Yes.
And then I square it.
Yes. Then you add those.
And then I find the total.
Yes.
Yes.
So this 2,868 was different.
Was different. I had about 3,366.
Okay, just a minute. You had the 3,000?
366.
3,366, like this. Okay. Okay, we can correct this together. 3,366 divided by 11. So
yeah, yes.
We find our variance to be 306. That was your 306.
Yes, 306.
Okay. Thank you. So the next thing we do is we want to find the standard deviation. So now the standard deviation is just the variance under the root.
Under the root.
Yes, so 306, let's put it under the root. The square root of 306 is 17.49.
49.
Yes.
Yes.
So it's 17.49. Okay. Thank you. Then we want to find the coefficient of variation. Coefficient of variation, we said it's the standard deviation divided by mean.
Over mean.
Yes, yes.
Times
100. So 306, I mean 17.49 divided by Our mean is 15.
Yes. Jim class Mairo. Now we
Okay. So
sorry for that.
okay. So it's supposed to be 116.
Yes, exactly.
Point 6.
116.6.
Exactly. Thank you. So
or 7 after rounding.
yeah. So that's how we can use this data to calculate. We can find the mean, we can calculate the median, we can calculate the variance, the standard deviation, and the coefficient of variation. So this marks the end of this part. We can now go to what is called standardizing data, Z-score.
Okay.
Yes. So all we need to do is to learn how to compute Z-scores from the distribution that we are given in the data. So
Okay.
basically, if we are dealing with the sample, the formula is X minus X bar over S. That is the Z-score for a sample. That's the Z-score for a sample.
Okay.
Yes. So, for instance,
in this case, the S stands for
sample standard deviation.
Or the S.
Yes, this is the standard deviation for the sample.
Okay. Okay.
Yes.
Okay.
So, if we are given this data here, 0, 2, 4, 6, 8, 10, this is our data. And most of the times, if we are dealing with the standardizing data, the mean is already calculated for you.
Yes.
They have added all these, they got 30. How many measurements in the sample? 6. We find our mean as 5.
Yeah, 6.
Yes. The standard deviation is already calculated for you, 3.74. So we want to find Z-score. For what? If we are dealing with, you have seen the way they have tabulated here in the table. This is X. Then
Yes.
we need to subtract the mean, which is 5. And we are dividing by the standard deviation. Yes.
Okay.
Yes. So the Z-score for a data of 0 with mean of 5 and a standard deviation of 3.74 will give us negative 1.34. 0 minus 5 is negative 5. Negative 5 divided by 3.74. Negative 5 divided by 3.74. It gives us negative 1.34. So that's how we calculate Z-score. Okay. So.
Okay. Just able to repeat the last statement. The last statement.
Okay. So no. we are saying the Z-score for a data of 0 with a mean of 5 and a standard deviation of 3.74 is negative 1.34.
Yes.
Exactly. So the Z of the data of 10 and a mean of 5 with
Yes.
a standard deviation of 3.74 is 1.34.
Yes.
Exactly. So that's how we calculate. That's how we calculate the Z scores of a sample data. Okay.
So like this information, then they ask you to calculate the Z score.
Hello?
I'm saying in the exams, sometimes do they give you this information already, whereby they've given you the mean, they've given you the standard deviation, then
Yes.
they ask you
To find the Z
calculate
score.
the Z score.
Yes.
Okay,
This
thank you.
is given. As we go to, when we start dealing with the probability, binomial and Poisson,
Yes.
that's where we're going to use Z score very much. We are just introducing the concept. Okay.
Okay.
So what we are saying here is that a Z score of more than +5 or less than -5 would indicate a very, very unusual score. So generally, Z score, the maximum is -4 and +4. When we calculate and we find anything above that, then something should be very unusual. Something should be very unusual. So here we are told that
Okay.
if the data is normally distributed, 95% of the data will be plus or -2 standard deviation above the mean. So if the distribution is 95%, then the data will be between positive or -2 standard deviation. So they have just given us these assumptions. 95%, it is -1.96 or +1.96. 99.7%, it is -3 and +3. 99.99%, it is -4 and +4. That's why this should be the maximum, because we are almost 100%. So basically, that's what they are saying. Okay. So we want to look at what is called 5-number summary. Here, they are saying when examining a distribution for shape, sometimes the 5-number summary is useful. We have decided to identify the smallest number, then we identify the median, and we identify the largest number. Then what we are saying is our lower quartile will be between the smallest number and the median. Then our upper quartile will lie between the median and the largest number. That is according to the 5-number summary theory. So we have got this data distribution, which we have earlier looked at, 2, 3, 8,
Yes.
8, 9, up to 63. We want to identify our median.
Yes.
We identified our median between 10 and 10.
Yes.
That's where our median is. So we are saying,
Yes.
if you put the parenthesis, a bracket here and a bracket here, we are going to count the third observation. If you count 1, 2, 3, 4, 5, 6, in the first part, we have got even numbers. So we don't have the median.
Yes.
Exactly. So we pick the two numbers which are at the center, 8 and 8. Okay? You pick the two numbers that are at the center, add them together and divide by 2. That is your median of the lower part, which becomes your first quartile.
Okay, so we are saying
Yes?
from the middle,
Yes.
from the middle,
Uh-huh.
the numbers to our left hand
Yes.
side.
Yes.
Now the number in the middle.
Yes. So when you
Okay,
break your
quartile.
data, you find the median of the half. The median of the lower half is your lower quartile, and the median of the upper half is your upper quartile. That's why I was saying the lower quartile is not 25%, but it is a number immediately above 25%.
Able just to repeat the statement where you said the median of the lower the median of the lower
The median of the lower part. Yes, the median of the lower half.
The lower part.
Yes. The median of the lower half is your first quartile or the lower quartile.
Okay. Okay.
Yeah, yes. And the median of the upper half is your upper quartile or the third quartile.
Okay. Okay.
Okay. This is what is called a box plot. This is what is called a box plot. When you look at the box plot, we usually use the same information or the knowledge that we were using in calculating the lower and the upper quartile. So what we do is, if you are required to use a box plot to present your data, you have seen we have drawn these lines, the vertical lines, where the data is lying, 0, 10, 20, 30, 40, 50, 60, 70. So the vertical line drawn within the box is the median. So this vertical line that is drawn within the box, I'm sure you are able to see this different color here.
Yes, I can see, but although I cannot see your cursor.
It should be somewhere here.
Okay, yes, I've seen it.
Yes. So this line, the vertical line that is drawn between or within the box, this is our what? Median. So when you are drawing, you first draw the horizontal line here, put the numbers, and put these vertical lines on these numbers, the way we draw the number line. Then you have calculated, we calculated that our mean was 10. Then our median,
yes,
our mean was 15 and our median was 10. So we first locate the median. So we are going to put our box where the mean is here. Then the vertical line, yes. The vertical line at the left side of the box is the lower quartile. We calculated our lower quartile. It was 8. You remember?
8.
Yes.
Yes. Yes.
So
yes.
we are going to paint 8 here, which is lower than 10. You see where the 10 is? So our lower quartile will be on the left side of our median. Then the vertical line at the right side of box is our what? Upper quartile. So we are going to paint this because our median is this line, okay? So our lower quartile is on the left of the median and our upper quartile is on the right of the median. So we paint that. That is how you present your data using a box plot. So it will look like this. That's how it will look like. We have removed those horizontal lines for the numbers so that we remain with this thing. So in short, this is a demonstration, a working of how to present a box plot. But the actual answer should look like this. Is it okay?
Yes, sir. Yes, sir. We have to get.
Thank you. So that's how we prepare the box plots. We can look at frequency distribution. We are trying to be a bit fast. Today it looks like the Zoom only gave us about 40-45 minutes. Okay, so frequency distribution. This one is very important in your syllabus. It is one of an examinable topic. So, the way frequency distribution is, all we need to know is how to plot some graphs. We will look at the histogram. We'll look at, I also saw the cumulative frequency curve, and sometimes even the bar chart, the pie chart, all those. Yes. So, when you look at this example, they took a sample of 200.
Yes.
Yes. And when these people were interviewed, the responses ranged from $520 to $590. When you look at this, 520 to 590, you are able to calculate the range.
Yes.
Yes. In a frequency distribution, one thing that I need to make an emphasis is the difference which exists between a range and the interval width. Most of the students confuse the two. The range is not the same as the interval width. These are two different things. So, how do we calculate the range? We learned yesterday that the range is equal to the largest measurement minus the lowest measurements. Meaning, it is 590 minus 520. We get the range of 70. So our range is 70. But the width of interval is range divided by number of classes. So what you do is from 520 to 590, how many classes are there?
We count it.
Yes. No, in this question, actually, they gave us to say there are 7 equal intervals. So, yes. So, the number of classes is 7. So, you discover that the interval width is 10, while the data range is 70. So, these are not the same.
Yes.
Okay, so once you calculate the width of interval, then you are able to develop a frequency table. So our frequency table will be using a class interval of 10, which we have calculated. So we'll start from 520 to 530. That is the first class, which has an interval of 10. Then, yes, then the second class will be 530 to 540. So we are going to put up those classes up to 590.
Yes.
If you count these classes, for sure there will be 7. Okay, so once we find these intervals and we have formulated the classes, all we need to do is we are given the frequency. A class of 520 to 530 had a frequency of 6. Yes, so we put the column of the frequency there. When we add the total frequency, it should give us the total sample size. Okay? So that's how we can prove that our frequency is correct. When we add them, they should give us a 200, which was our sample size. Okay? So,
yes.
Okay. Then we can try to find the percentage.
Yes, sir.
So how do we calculate the percentage? The total sample size is 200, or the total frequency is 200. So yes, the percentage for the first class, the percentage frequency is 6 divided by 200. It gives us 3%. Yes. Are you able to get 3%?
Yes, sir.
Exactly. Then the second class has a frequency of 30. Divide by 200, multiply by 100, it gives us 15%. So this is how we calculated these percentages. So once we do that, the next thing we need to do is to find the cumulative distribution. This is the frequency distribution. So we go to the cumulative distribution. Now, when we are dealing with cumulative distribution, what are we cumulating? We are cumulating the frequency. So we are cumulating the frequency.
We are
Cumulating means adding. We are adding the frequency.
yes.
Yes. So the first class ranges between 520 and 530. Because we are about to plot this graph, we are going to pick 520, 530, 540, just like that up to 590. So less than 520, the frequency is 0. But less than 530, meaning above 520, but less than 530, the frequency is 6. Then less than 530, I mean above 530, less than 540, the frequency was what? The frequency was 30. So 30 plus 6, this is 36.
Yes.
Yes. Then 550, it is this 36 plus the frequency of 550, which was 38. Okay? So 36 plus 38 gives us 74. That's how we found the cumulative frequency. So just keep on adding these. So that the last class, which is 590, will have a cumulative frequency of 200, because these are additions.
Yes, sir.
Okay.
The last class, which is 590.
The last class is 590. So it should give us the total sample size, because we were adding. Class 1
yes.
is 0, okay? Class 2, we add to class 1. Class 3, add to class 2. Class 4, add to class 3. Until we find the last class will give us the sample size, which is the total frequency. 200.
Yes.
Exactly. So even the percentage, we want to find the cumulative percentage. This is cumulative frequency. That's cumulative frequency. So we can find the cumulative percentage. Okay? Cumulative percentage, the first class had 0. The second class, the percentage was 3. The third class, the percentage was 15. So 15 plus 3, 18. So we are just adding there, yes, until the last class gives us 100%. That's what we are doing. Okay, so once we have done this, the first table, now we can draw what is called a frequency histogram. A frequency histogram. Basing on this, the first frequency table. So 530, the frequency is 6. 540, the frequency is 30. 550, the frequency is 38. So when you are drawing a frequency histogram, you use the frequency table. Sometimes they may request you to draw a relative frequency histogram. Okay?
Okay. Yes, sir.
A relative frequency histogram, we will also look at this one. What could have happened is, this is a frequency. We were supposed to formulate a relative frequency. Relative frequency is like a percentage, except we don't multiply by 100.
Okay.
Yes, so it is 6 divided by 200. It gives you 0.03. That is your relative frequency.
Okay.
Yes. So the second class could have been 30 divided by 200, which is 0.15. That is your relative frequency.
Yes.
Exactly. So this is how we plot the histogram. We use the frequency table. 520, the frequency is 6. 530, 30. 540, frequency was 38. Okay? That's how we draw it. Now, after drawing the frequency histogram, you must be able to draw the polygon. So, how do we draw the polygon? The polygon, you put stars at the center of your class. 520 to 530. What is your midpoint?
You 530 plus 540 divided by 2.
Yes, that will be 525.
Yes.
Your midpoint will be 525. So at this point, put a star here. Then you go to the next class. Find the midpoint, put a star. Third class,
Yes.
put a star. Put stars at the middle of each class. Once you put those stars, draw a line passing through those stars. That is what is called a frequency polygon. It looks like this.
So, sir, like in the exam room,
Yes.
if they ask you to draw the
Frequency polygon.
the frequency polygon,
Yes.
are you supposed to make it, you make a table where you say the total total number of elements, in that case 200, you divide by the frequency? Are you supposed to make another column or you can just do it like what you're explaining, or just
the best is, if they want a relative frequency, you should have added another column here.
Yes.
Yes.
Okay, thank you.
Thank you.
Thank you.
So I'm sure this one has answered your one part in the assignment. There was a question about polygon.
Yes.
So that's how we draw the
last.
Yes, the frequency polygon. Exactly.
Yeah.
So for a cumulative frequency, as we said, you are using, so for a cumulative frequency, we go to this table now. Have you seen? We are plotting, this is our x-axis, and the frequency is our y-axis. So if you are drawing a frequency distribution, you use this frequency. If you are drawing a cumulative frequency distribution, you use this. Cumulate the frequency. That is the only difference. That's why when you look at the way it looks, because the frequency is cumulated, So it will look like this. The x-axis will be the same, but the y-axis will change because in the first, we didn't cumulate our frequency. In the second example, we cumulate the frequency. So the y-axis figures will be different and the diagram will look different. That is basically how it is drawn. The only thing that I wish to mention is how we draw histogram. You have seen what is here.
Yes.
Are you able to see? The
Yeah,
reason
like the line is breaking.
Yes.
The zigzag line.
Yes. The reason is that the histogram, the x-axis does not begin from 0. So we have to cut it. So remember to cut your line. X-axis must be cut here throughout. Unless there's any question, I think we can end here for today so that we don't bust the brain. But if you look at what we have done, we are just remaining with one part. Maybe you can allow me just to finish this. There's only one more part that we can cover.
Okay.
We can finish it?
Yes, we can cover.
Thank you.
Yes, sir.
This is what is called a contingent table. Now, you are going to understand this very well when we start dealing with probability. Now, when we will be dealing with the chi-square, if, for instance, you have a question where they want you to find the probability of picking a male employee who is studying purchasing and supply. If you look at such a question, you have got two things. A person must be a male and he must be studying purchasing and supply. With that probability, you need what is called a contingent table, where in your horizontal line, you can put two variables. Then in your vertical line, you put two variables. So for you to find the probability of, like in this case, we have got two gender, male and female. Then we have got two political parties, Republican and Democratic. So we want to find the probability of picking a male candidate who is a Republican.
Okay.
So in that question of probability, you use a contingent table.
Okay.
So what is the probability of finding a male candidate who is a Republican? You first find what is the total number of male in the population. You are given 250. What is the total number of female in the population? 250. So the total sample was 500.
Yes.
Then you are asking yourself, here you are dealing with how many Republican candidates. There were 250, Democratic candidate 150. So you are going first to add this column here, 500 plus 500, you find 1,000. So
Yes.
the probability of a male candidate who is a Republican is 250 divided by 1,000. Not by 400, no. So the probability is 250 divided by 1,000, which will give you 0.25 or 25%. So when we begin probability, remember this concept. it will be very useful in probability.
Yes. Okay.
So, yeah, so basically, the next session, we are going to start probability.
Okay.
Unless there's any question so far before we close.
No, I'm okay.
Okay.
At least I'm getting there.
Thank you very much. So we are to start our most needed topic, probability. We are likely to start. When is our next meeting? Sunday?
Today is Sunday.
Okay.
Sunday.
Yeah, so Sunday, I'll make sure that tomorrow I send the other chapter for probability so that we start looking at probability.
Okay. I'll appreciate.
Okay, then I will spare some time probably next week so that we can look at the assignment.
Yes, yeah, I really appreciate.
Okay.
I want to clear.
It's important, my brother.
Yes, I want to clear. Thank you very much.
Okay, thank you very much. Have a blessed evening.
Thank you, sir. Thank you very much.
Thank you.